Okay, today our lesson is derivatives of exponential functions. We have seen what exponential functions are in advanced functions or functions. So as definitions, let's see if I have log of x to the base of b is equal to y, this is called logarithmic form. If I change it to b to the power y is equal to x, it's called exponential form. These two are equivalent, they are the same. Logarithmic form, exponential form. If I write log of x without any base, it automatically means base is 10 and we call it common logarithm. If it is log of x to base of e which is special number or Euler's number, then we call it ln x, we don't call it log x, ln x. And this is called natural logarithm. So we'd like to derive today fx equal to b to the power x. First, let's derive it using the definition of derivative or using the first principles. So f prime x, the derivative of that will be using the first principles, which is b to the power of x plus h. We have a limit here as h approaches to 0 over b to the power x over h. So first principles, instead of x, I substitute x plus h. Then this is equal to limit of as h approaches to 0, b to the power x plus h means b to the power x times b to the power h minus b to the power of x over h. Then limit of h approaches to 0, I take b to the power x as GCF outside, b to the power h minus 1 over h as h approaches to 0. So now we'd like to see b to the power h minus 1. B to the power x does not depend on h because it does not have h. Therefore, I take it outside, limit of b to the power h minus 1 over h as h approaches to 0. So if we say the derivative of b to the power x is that, it doesn't look like nice. This is not a very nice number. Therefore, if I give b is equal to 2.718 and so on, this number is called Euler's number, which is said E. So this will be b to the power x when b is equal to E, then this number here, the whole number, limit of this number, if you use your calculator with E is 2.718, you will get 1. Therefore, we say the b is changed to E, it will be e to the power x. So that's why the derivative of e to the power x is e to the power x. So what we are saying is if fx is equal to e to the power x, then the derivative of that will be the same, e to the power x. If fx has a function in the exponent g to the power x, then the derivative of that will be the same, e to the power gx, and then the derivative of the exponent. These are the two basic things here. So I always multiply by the derivative of the exponent. Okay, so this is when b is equal to e. How about if b is any number? Let's say fx, we got b to the power x, and if I say ln of b, this comes from if fx is equal to e to the power x, then I can say the derivative of that will be e to the power x times ln of e. But ln of e is equal to 1. Therefore, we don't write ln of e. We just say the derivative is e to the power x. The same way, if fx is b to the power x, then the derivative of that will be b to the power x times ln of b. So, to review this one, we said fx is equal to b to the power x. If b is e, then the derivative is e to the power x. If b is any number, then f prime is b to the power x times ln of b. Let's see some examples here. Example A. Okay, so let's say y is equal to e to the power 3x. Therefore, as we said, the derivative of that will be dy dx will be the same, e to the power 3x times the derivative of exponent, which is 3. So I write the number first, e to the power 3x. B. If y equal to 6 times e to the power 4x, then dy dx, the derivative will be 6 stays the same, e for x stays the same, multiplied by the derivative, which is 6 times 4, 24, e to the power of 4x. If fx is equal to e to the power minus x squared plus 5x, then the derivative of that will be, which is f prime, the same, e to the power minus x squared plus 5x, then the derivative of the exponent, which is 2x plus 5. These are all with e. If e is, instead of e, I write b, d, then we have y equal to 3 to the power of 5x minus 1. Then dy dx is, I have the same 3, 5x minus 1 times the derivative of exponent times ln of 3. So I write as it is. I write ln 3. I can write ln 3 first or the derivative first, doesn't matter. The derivative of 5x minus 1 is 5 ln 3. Okay, so if I had y equals e to the power 5x times 4 to the power of 2x. These are two functions, therefore I have to use the product rule. So dy dx is equal to the derivative of the first function, which is e 5x, times the derivative of 5x, 5, the second function, which is the product rule, plus the derivative of the second function, which is the same, 4 to the power 2x, times the derivative of exponent, times ln of 4, times the second function. Okay, so derivative derive the first, multiply by the second one. We derive the first, multiply by the second one. So if I have now to simplify this, I have to take the GCF. The GCF will be, I have e to the power 5x, and then I have 4 to the power 2x, then I have only 5 left here, plus, then we have 2 ln of 4. Let's see one example. F. If I have y equal to e to the power of sine 4 to the power of x, then dy dx will be the same first, e sine 4 to the power x times the derivative of the exponent. The derivative of sine we have seen is cosine 4 to the power x. And then the derivative of inside, derivative of 4 to the power x is 4 to the power x ln of 4. Okay, so these are typical examples of exponential functions.